All right, so we're going to continue with some more examples of solving equations. Example number 7, solve negative 5t equals 60. And in algebra, this is how we represent multiplication. We don't write the time symbol necessarily, but we do understand that this is multiplication. So negative 5 times t equals 60. Again, we're going to follow the steps. We're going to get the variable by itself, which number needs to be moved or removed. Some people think of it as moving, some people think of it as removing. Well, we need to remove that negative 5 away from the t. We want to isolate t. We don't want negative 5 t's, we just want a single t there. So to remove that negative 5, we must do the inverse operation. And what operation will we use? Well, since this is multiplication, we will use division. Right? Let's go through the steps. You want to draw that river line. I'm using blue, so I'm just calling it a river. If that helps you remember, great. I'd need it for organization purposes because sometimes my handwriting gets a little messy. I don't know about you, but I have pretty messy handwriting when I write things down. We make our plan. Our plan is to divide by negative 5. And I like to write division like this because this is standard writing of division in algebra. Making it look like a fraction, and it's actually very useful because if we happen to have a fraction for an answer, then it actually looks the same. It's kind of a neat little thing. We'll get into that a little bit later. Simplify down. Negative 5 divided by negative 5 is equal to 1t. If it helps you, you can put a 1 in front of that. It's not necessary, but you can put 1 there. 60 divided by negative 5 gives us the negative 12. And we can always check to make sure that we got it right. Right? And indeed it is. Negative times a negative make a positive. 5 times 12 is indeed 60. All right, let's try this one. 15 is equal to 6n. And if some of you are thinking, well, why is the variable on the right side? It's okay. Remember, an equation is just a question of balance. Both the left and the right sides are representing the same thing, so it doesn't matter which side has the unknown amount on there. It can be on the left side, it can be on the right side, and in fact, when we get more complicated questions, sometimes we have a lot of stuff on both sides, and we have to simplify a lot of things. So it's okay to be on the left side or the right side. All right, let's draw our line, our plan. We need to divide by 6 to get that 6 away from the n. I don't want 6 n's. I don't want 6 nuts. I want 1 nut. All right, how much is 1? Well, if we simplify, we find out that 1 n is equal to 2.5, 2 5/10. Okay, depending on how we need the number, we could write it as a decimal, or as a mixed number, or as an improper fraction. And even right here, we see that improper fraction, which is why I said I like to write it this way, because there, if our answer was an improper fraction, there we go. The answer is even right there. So in this case, 2.5 works just fine. Let's check our answer. 6 times 2.5 is indeed 15. 6 times 2 is 12. Half of 6 is 3. 12 and 3 do make 15. All right, another multiple choice one for you. Pause the video if you need to think about it. If you chose C, v is equal to positive 43, you are correct. Alright, here's one with division. Now again, this looks like a fraction to a lot of people, but in algebra, this is a way of writing division. Alright? If you don't like fractions, that's okay. We get a nice way to get rid of them. Since the inverse of division is multiplication, if we just multiply by that denominator, we can clear the fraction out. It's a nice little trick because we're undoing that division, the same as we've been undoing the other steps of addition, subtraction, and multiplication. Undoing division is just multiplying. I don't want x divided by 4, I want all of x. I don't want 1/4 of x, I want the whole thing. So if I multiply by 4, that will get me back to my original number there. See, so our plan is to multiply both sides by 4. I'm undoing that division. Simplify, and we get 1x is equal to, in this case, negative 48. And we go back and check it because we always want to check it. Sure enough, 48 divided by 4 is 12. Negative divided by positive gives us a negative answer. All right, let's try this one. All right, what's our plan here? You can pause the video if you need to think about a plan. All right, we have 2x divided by 3 equals 18. Some people might see that as 2/3 too, depending on what you see. You could see it as 2/3. There is a way to work with that as 2/3 as well. But we're going to look at it as 2 times x divided by 3. We're going to look at it in that sense. So we want to undo that multiply by 2, and we want to undo that divide by 3. In this case, we've got a two-step problem here. Okay, we want to clear that fraction first. Get that fraction piece out of there. Let's multiply both sides by 3 to clear out that fraction. If we simplify, we get 2x is equal to 54. Then we want to divide both sides by 2 to clear away the 2. Simplify, we get x is equal to 27. Go back and check. 2 times 27 divided by 3 does indeed give us 18. A couple more examples here. Number 12, which step clears the fraction in this one? Well, if you chose B, multiply by 5, you are correct. How about this one? You can pause the video if you want to write this one down and figure it out. All right, the answer is C, B equals 14. Okay, and you can go back, put that back in for B and check to see if that actually does work. All right, there were a few examples. Hope you enjoyed those. In the next video, we'll look at some more complicated ones.